In the previous module, we looked at the specific kinds of shares, preference shares and ordinary shares. In the next couple of modules, we'll develop some tools that will allow us to calculate the value of those types of securities. In the introductory topic, we talked about the value of a financial asset being the present value of all future cash flows, and we will return to that concept again in this topic. As we know from financial mathematics, in order to calculate a present value, we need an appropriate discount rate, which is a measure of the time value of money. Earlier in this topic, we looked at various names for the discount rate that we use in calculating the present value of a future cash flow. In the topic on financial mathematics, we generally use the term interest rate because most of our examples involved a bank deposit or a bank loan. An appropriate general term for the discount rate is the opportunity cost. The most common term for the discount rate when we're discussing debt securities is yield, or perhaps the cost of debt capital. For the remainder of this topic, the most common term for the discount rate when valuing equity securities is the required rate of return, or the cost of equity capital. Since we know that the value of any financial asset is the present value of the future cash flows, what are the cash flows that we would get from owning a share? One component is the dividends that we receive while we hold the share, and then the other component is the sale price that we get when we sell the share. Let's look at the situation from the point of view of a one-year investor. At the end of that year, the investor receives the dividend at the end of the first year and the price that he or she gets from selling the share. In order to calculate P0, the value of the security today, we need to calculate the present value of those two cash flows. Using one of the formulas that we developed in the financial mathematics topic, we know that P0 in this case will be the dividend at the end of the year plus the price that we get when we sell the share at the end of the year, discounted by 1 plus RE, where RE is the required return on equity. If we know the price of the share at any time, we can manipulate this equation to calculate the market's required return on equity. Once again, you don't need to replicate the following derivation, but it would be very useful to see if you can understand what's happening. All I'm doing is algebraic manipulation. Doing anything to one side of the equation is okay as long as you do the same thing to the other side of the equation. So what I've done here is divided both sides by P0 and multiplied both sides by 1 plus RE. Then we subtract 1 from both sides of the equation. Then we replace 1 with the fraction P0 divided by P0, which is obviously equal to 1. Since the two terms on the right hand side of the equation have the same denominator, we can move the P1 from the first term to the second term. The reason we've done that is to demonstrate that we can break up the required return on equity into two components. The first term is what we call the dividend yield. The dividend that you receive in a year divided by the price that you paid for the share at the beginning of the year is the rate of return that you have received by virtue of the dividend. The second component is called the capital gain yield. The capital gain is the change in the value of the share, P1 minus P0. If we divide that figure by the price that we paid to purchase the share, then we have an expression for the rate of return that we've received through the capital gain.